Hello, my name is Kavindra Chanalaki Vidya. My matrix number is 33DPC 20F1032. I would like to present Izod impact test. So the objective is to find the impact resistance of mild steel and cast iron. Apparatus used is impact testing machine. Impact testing machine evaluate an object capacity to withstand high rate leading and determine the service life of a part or material. Step 1. Select the Izod test specimen. I would like to select cast iron. The length of the cast iron is 75 millimeter. Breadth is the distance or measurement from side to side of something. The breadth is 9.5 millimeter. Depth is 9.44 millimeter. Depth of notch, the distance from the surface of a metal specimen to the bottom of the notch. So the depth of the notch is 4 millimeter. Step 2. Test for friction loss is conducted by adjusting the pointer to 164 joules. Then the pendulum is released by operating the lever without keeping the specimen. Loss of energy due to the friction is equal to 2 joule. Step 3. The Izod test specimen as per Indian standards IS 3766 uh, uh, equal 1977 is placed in position. Trial 1. Radius of curvature of striking edge, test piece, striking edge, angle of tip of striker, direction of impact, angle between underside of striker and face of test piece, and lastly supports. Step 4. The pendulum is released. The hammer strikes against the specimen, breaks it and swings further than the observation is noted down. Total loss of energy during transit of hammer is 5 joule. Energy for failure of specimen is 3 joule. Initial energy of the hammer is equal to 164 joule. Average loss of energy due to friction is equal to 2 joule. Total loss of energy during transit of hammer is equal to 5 joule. Energy for failure of specimen is equal to impact value equal to 3 joule. Step 3. The Izod test specimen as per Indian standard IS 3766 1977 is placed in position. Selected specimen is a cast iron, length 76.4, breadth 9.4 millimeter, depth 9.16 millimeter, depth of notch 2 millimeter. Step 4. The pendulum is released. The hammer striker strikes again the specimen, breaks it and swings further than the observation is noted down. Total loss of energy during of transmit hammer 6 joule. Energy for failure of specimen 4 joule. Trial 2. Initial energy of the hammer is equal to 164 joule. Average loss of energy due to friction is equal to 2 joule. Total loss of energy during transit of hammer is equal to 6 joule. Energy for failure of specimen impact value is equal to 4 joule. We move to trial 3. Step 3. The Izod test specimen as per Indian standard IS 3766 1977 is placed in position. Selected specimen is a cast iron. Length of cast iron is 74.5 millimeter. Breadth 9.42 millimeter. Depth is 9.36 millimeter. Depth of notch is 5.1 millimeter. Step 4. The pendulum is released. The hammer strikes against the specimen, breaks it, and swings further than the observation is noted down. Total loss of energy during transit of hammer is equal to 10 joule. Energy for failure of specimen is equal to 8 joule. So we move to observation. We got trial, loss of energy due to friction, total loss of energy during transit of hammer, energy for failure of specimen equal to impact value is equal to joule. So trial 1, we got loss of energy to friction is 2, loss of energy during transit of hammer is 5 joule, energy for failure of specimen equal to impact value is 3 joule. In trial 2, loss of energy due to friction is 2 joule, total loss of energy during transit of hammer is 6 joule, energy for failure of specimen equal to impact value is equal to 4 joule. For trial 3, loss of energy due to friction, we got 2 joule, total loss of energy during transit of hammer we got 10 joule, energy for failure of specimen equal to impact value is we got 8 joule. Average energy for failure of specimen is equal to 5.00 joule. Thank you.
Okay, hi, my name is Nur Aliz Rika bin Tazman. My matrix number is 33DPC20F1030. Today we are going to do the Izod impact test. So objective is to find the impact resistance of mild steel and cast iron. Apparatus used is the impact testing machine. Impact testing machine is to evaluate an object capacity to withstand high rate leading and determine the service life of a part of material. Step 1 is to select the Izod test specimen. So here we have to select the mild steel. Okay, selected specimen, mild steel. Length is 75.8 mm. Breadth is 9.5 millimeter. Breadth is the distance or measurement from side to side of something. Depth is 9.4 millimeter. Depth of notch is 5 mm. Depth of notch is the distance from the surface of a metal specimen to the bottom of notch. Second step is to test for friction loss is conducted by adjusting the pointer to 164 joules. Then the pendulum is released by operating the lever without keeping the specimen. So here we got the loss of energy due to friction EF equals to 2 joules. Step 3 is the Izod test specimen as per Indian standards IS 3766 to 1977 is placed in position for trial 1. As you can see here is the radius of curvature of striking edge. This is the test piece, and this is the striking height. This one is the angle of tip of striker, direction of impact, angle between underside of striker and face of test piece, and here is the support. Step 4. The pendulum is then released. The hammer strikes against the specimen, breaks it, and swings further than the observation is noted down. The test piece was not broken by striking energy of the testing machine, so the impact value is obtained indefinite. Observation for trial 1. Initial energy of the hammer is 164 joule. Average loss of energy due to friction EF equals to 2 joules. Total loss of energy ET during transit of hammer equals to indefinite. Energy for failure of specimen KU. Impact value equals to ET minus EF equals to indefinite. Okay, so for trial 2, the Izod test specimen as per India standard is placed in position. As we can see here, selected specimen is mild steel, length is 75 5.8, breadth is 9.5, depth is 9.4, depth of notch is 5 mm. Step 4, the pendulum is again released. The hammer strikes again the specimen, breaks it, and swings further than the observation is noted down. Total loss of energy during transit of hammer ET equals to 49 joule. Energy for failure of specimen equals to ET minus EF equals to 47 joule. Observation for trial 2, initial energy of the hammer is still the same, 164 joule. Average loss of energy due to friction, EF equals to 2 joules. Total loss of energy, ET, during transit of hammer is 49 joule. Energy for failure of specimen, impact value equals ET minus EF equals to 47 joule. Okay, so for trial number 3, still the same method. The Izod test specimen as per India standard is placed in position as we can see here. The length of 76.26, breadth is 9.3 32, depth is 9.48, depth of notch is 4.5 mm. So step 4, the pendulum is released, the hammer strikes against the specimen, breaks it and swings further than the observation is noted down. So here we have total loss of energy during transit of hammer, ET equals to 49 joule. Energy for failure of specimen is ET minus EF equals to 47 joule. So observation for total 3 trial. Trial first, loss of energy due to friction, EF 2 joules. Same with the trial 2 and 3. Total loss of energy ET during transit of hammer for trial 1 is indefinite. For trial 2 is 49. For trial 3 is 49. Energy for failure of specimen, ET minus EF for trial 1 is indefinite. For trial 2 and 3 is same for 47. So average energy for failure of specimen is equal to 47 joules.